Lesson 673, Q1, Implementing General Strategies for Factoring. In this problem, we are asked to completely factor the trinomial 5y cubed minus 15y squared minus 270y. There is something else we should always pause to look for first. When factoring any polynomial, we should check to see if there is a greatest common factor, or GCF, that all the terms have in common. In each of the three terms, doesn't it look like there is at least one y factor that can be pulled to the front? But what about the coefficients? Is there a number that evenly divides 5, 15, and 270? And when we find that number, is it the biggest possible number we can use? The number 5 divides 5, 15, and 270 evenly, and we know it is the largest number possible because there isn't a number bigger than 5 that will divide into 5 a whole number of times. So, let's pull out both a factor of 5 and a factor of y from each term of the trinomial. As we pull 5 times y to the front of our expression, we now ask ourselves, what is left over in each term? If you would like, pause the video and try to determine what is left over in each term when it is divided or factored by 5 times y. When you are ready to check your response, resume playing the video. We find that when 5 times y is factored from our first term, then y squared is left. If 5 times y is pulled out of the second term, negative 15y squared, we find that negative 3y is left over. Now, for our last term, we repeat the process. We determine how many times 5y divides into 270y. Notice that if we factor a y to the front of the expression, it takes all the variables from the last term, so we will only be left with a number. To figure out that number, divide negative 270 by 5. This gives us negative 54. Wow, that trinomial looks much easier to factor now. This is why taking out a GCF at the beginning is so important. Now we need to see if the trinomial y squared minus 3y minus 54 can be factored into a set of binomials. First, let's consider how we can factor or break down y squared into its component parts. Luckily, we only have to consider one set of factors. Only y times y will yield a product of y squared. So we definitely know the first terms for our binomials. We can place a y in both of those locations in the parentheses. To find the other terms, start at the end of our trinomial. Let's create a list of factors that multiply to be negative 54. Don't forget that we have to consider all of the cases that will make a product of negative 54. That means that in one instance, it may be negative 1 times 54, but another pair of factors includes 1 times negative 54. Even though the digits are the same, in one set the 1 is negative, and in the other set the 54 is negative. After we have listed all of the possible factors, to determine which set to use, we shift our focus from the negative 54 to the middle term, the negative 3y. Since this term is the result of adding the products of the outside and inside terms when multiplying the binomials, we need to use the factors that will combine to equal negative 3. As we go through the list, we see that 6 and negative 9 sum to negative 3. So those are the factors we use. We will place the numbers positive 6 and negative 9 into the second terms of our binomials. Once we fill in the second terms of our binomials, we see that when 5y cubed minus 15y squared minus 270y is completely factored, it is equivalent to 5y times the quantity of y plus 6 times the quantity of y minus 9.